and welcome back to my workshop. So today we're going to be cutting and manufacturing these two parts for our X2 belt conversion, and we'll be cutting them out of aluminium plate on a 1690 CNC Router. Okay, I've just come back from a bit of a shopping spree down the local metal merchants, and you see I've got some solid bar there to make pulleys from. I've got some 10mm plate, I've got some 6mm plate, 12mm plate. Now this is to make the end plates for the X and Y and Z axis. Some bearing block material too. That's 25mm by 50mm, and some nice solid aluminium box section with a 6mm wall to house the the bit of a standoff for the couplings, and to sort of stand off between the end plates and the end plate of which the NEMA 23 stepper motors are going to be connected to. So like I say, I like to make everything with a big margin of butch factor. Anyway, so this is prototyping. So what I've done is I've actually removed the electrical box because it was in my way, and SIEG probably could have mounted the electrical box a little further down. But it actually stands slightly proud, which limits, how far we can come out rather. So what I've done is I've made a bit of a template, and I've marked out the largest. I still like to have a relatively slow speed with high torque. So the largest permissible pulley, obviously I'll have a two-stage pulley this end, and a two-stage pulley on the motor end. So as you can see, that fits on there pretty perfect, and I've made one for the motor itself as well. Okay, let's zoom you in there a bit. Okay, so you can see the general idea of design here. And what I like to do, save wasting material and wasting my time, I like to make just a simple cardboard template, draw it all out, cut it out, put it on there, make sure it fits. Then I'll draw it up into either CAD or SolidWorks or something like that. But I like to be sure of what I'm doing. Here's the action. There's a pivot point here, and this is where the adjustment stay. In actual fact, what I'm going to do is take the. Okay, here is the actual little, should we say, lever handle that locks up on the gib. That's not going to be required. So what I'm going to do is I'm going to remove that from there and use that to be able to lock the motor down. It saves me making something, and cuts down on the price of the actual kit if you use your existing locking mechanism for the gib, because you're not going to use it, you're going to throw it away. So now I can confidently, that's a bit bright, isn't it? This is my German Shepherd, who's about 10 years old now, and spends a lot of time with me. But why I brought you into my office is because I've just drawn up this part. As you can see, I've drawn up this part here. It looks something like it. In actual fact, it's the exact measurements now. I've just got to clip the corners. It was a little bit too long to record this, longer than what I actually wanted to put into this video. So I will probably at a later date do a full video on how to use ATCAM Express 2015 as a a CAD system, because it's got a full CAD program built into it, and show you guys how simple it is to use. Anyway, we'll move on. I'll just finish this drawing, do the toolpaths, and hopefully get this on the machine and cut it. So here we have the drawing of our part, drawn up very accurately in ATCAM, and well, it resembles, I think, what we've cut out. So what I've done now is I've individually made all the tool paths. You'll notice in the center the two pockets in the middle that I've got a hole. What I normally do is I drill a hole in the middle because end mills don't really like plunging into material, at least not with a router anyway. It's a little bit you can create a lot of tool chatter that way. So I find if you drill a hole through the middle first, then do the pocket with an end mill, you get a much better result. So that's it in 2D. Now we'll switch to 3D and we will run the simulation of all the tool paths, which is simply that. So that is the end result, and that's the part that we require. I will put up more videos about ATCAM and SolidWorks in the future, but I think for now I've done enough for what I want to achieve with these videos. So now it's time to turn this nice piece of 9mm aluminium plate into conversion plate to drive belt instead of those damn gears. So I'll just show you a few little interesting things about Mach 3. If you've never used Mach 3, I'll just show you some of the very simple, shall we say, controls and some simple things that might help you to understand Mach 3 a little bit. I also have NC Studio. Now, I've learned a lot about NC Studio over the last 4 or 5 years, and they've made a lot of changes to it, and I believe it behaves itself a lot better. I mean, you know, new programs all have tedium problems, even Windows. So my Chinese partners have convinced me to try NC Studio again, which I will, with you guys, and we'll see what we can make of it. But personally, I like Mach 3. So, okay, so I'll show you a few things about Mach 3. Incidentally, Mach 3 and NC Studio are the controlling programs that administer then the information about X, Y, Z and the speed of which it is administered, and the rate in which you can actually alter things. This is the administering program that tells the CNC what to do. So basically there are two mainstream ones, Mach 3 and NC Studio. Some of my earlier videos you will see some information about NC Studio, because I originally bought this machine with NC Studio, and I had a few things happen. I wasn't really happy with it, so I converted to Mach 3. So without more ado, I'll show you some things about Mach 3. To load a program into Mach 3, this is the screen where it's going to appear. but I need to bring the cut cursor up here and open the file section. And open that, and you'll see the first one off the rank here is load G codes. Click on that, and this is off a stick that I just put in. So what I want to do is spot the drill holes. So what that means is I've got like a center drill in the router at the moment, and it's going to go and spot all the holes where I want drills drilled in it, because otherwise sometimes the drill can wander. It can be as much as a half a millimeter off. So that's what we're going to do now. So to load that one in, spot drill, so double click, and there it is, it's in. And this is what G code looks like. Just X, Y coordinates and speeds and beats. Okay, as we are, you can't see me down there. As we've just mentioned about pendants, interestingly enough, within Mach 3 there is a pendant as such that you can pull up on screen just by pressing the tab key, and there is the pendant there, fully operating pendant. Okay, some interesting things about the pendant. You can actually alter the percentage of jog just by altering these here. 30%, 25%, 20%. I'll leave it on 20%. This is you can move it X, Y, and Z just by pressing these tags. A couple of other interesting things about Mach 3 is these are the DROs. These actually, it's all set up for millimeters for mine. So what I'm going to do now is show you, okay, this is highlighted, this is machine coordinates. I'll just show you what a machine coordinate is. Okay, machine coordinate is the machine home position, okay, which is right over, as far over this corner as you can go. Hence all the DROs are reading all zeros. Now if I press this here, now that now gives me the work offset. Now prior to starting this video up, I have put the piece of material on here, found the center of it because I drew it in ArtCam, everything from the center, alright? In other words, I've made the start of the program in the center of the material. So I pre-zeroed the tool into the center of the material, and so what I can do now is, if now I'm in this screen, this DRO screen, which is the work offset now. If I hit this button now, this thing will automatically go to that 0 point, like this. Isn't that clever? So we can check to see whether, yeah, that is actually pretty well perfect. Normally you can sort of just get a bit of paper, a bit of thousandth of an inch, and just to manage to get it under there. So I know that is actually on the 0 point there. So I know it's all set up correctly. So now I can lift it up. Right, well, actually I can do it with this. Let's get rid of the, oh, to make the pendant go away again, you just press tab again and it comes back to the screen that you want. Obviously you can fully control the machine from this computer pad. So just press page up to bring this up, and left, right arrows, and page down for the Z height to go down. So we'll just fire it up and we'll run this G code now, which is the spot drilling. Okay. A couple of little things I want to show you about these CNC routers that the manufacturers don't tell you, and I will remind you that this particular 6090 CNC router has been heavily modified by myself. So it is not as you would buy from a Chinese manufacturer. As some of you will already know, I'm actually starting up a factory in China to produce these modified to European and American standards. So they will be coming out hopefully before October this year of 2016. So I just want to show you a couple of little pointers, and one of them is quite important actually, and I'll show you that now, to do with the actual water-cooled spindle. Now, depending on how you have yours connected up down the bottom, down onto the pump there, in my case this is the feed to the spindle, and this is the feed back to the tank. So what you need to do is at least twice a year. If you don't, what I normally do is I normally, when if I'm running the spindle for a long period of time, I normally put my hand on it, and you can tell whether it's getting a little warm or not. And one of the reasons why it does get a little bit too warm, even though it's water cooled, is that sometimes you can get a bit of muck caught in here in the galleries, in the cooling galleries inside here. So what I do every now and again, to make sure everything's going just fine, is just switch it on. Okay, beginning to come through, I think. There we go, that's okay, that's perfect. And you'll notice it's a green color. Right, now this is one of the main things I wanted to show you. Okay, so I've proven now that we've got a flow through. We'll do that back up. Doesn't have to be done very tightly. Just nip him up. Just nip him up firm. Now, what's in here is ethylene glycol. So that green stuff is the same stuff as in your car. It's anti-freeze, anti-boil, and what's more important, and more important to this machine, is anti-corrosive. However, in Tasmania here it does get down to freezing, and you know, especially if you're in an area where it does get cold in your workshop, unless it's heated, you need anti-freeze. Now, the manufacturers of these machines, I have not seen one of them that suggests you even doing that. Well, I'm telling you that you need to do it. It'll stop corrosion inside your cooling system, inside the motor here, or however, this is stainless steel. There is some aluminium parts in here too, but as you know, aluminium can still corrode permanently in water. So this stops all that, and it stops it freezing. So it's a very useful and I think an essential thing to have no matter where you are in the world. Doesn't matter if you're in the Arizona desert, you need to stop it corroding. So there you are. There's a very worthwhile and useful tip, and one thing that I will recommend when our machines come on the market will be in the operational manual. Incidentally, the next clip that I'm just gonna put in here, because I've had a lot of people send me emails, where can we buy these machines, how much? And well, at the moment we don't have firm pricing, we don't have a firm date yet, but I just wanted to let you know that what we were doing in the background. A lot of people have asked me about my Chinese contacts. Well, they're business partners in a different business, but we've decided to go into this venture as well. And yes, they speak perfect English and write perfect English. In some cases better than I do. So there is no problem with eventually, when you are able to send emails or place orders, you are going to be able to communicate with people that understand perfect English. So here's a clip of my partner Eddie. So here we are at the town where Confucius lived his life, and this is a monument to Confucius and learning, I understand, and the Chinese way. Incidentally, this is Eddie with the mayor. Eddie is my partner in China and his wife.
Coffee.
This is the chairman and the mayor of the city of Confucius, and they're hosting a meal on behalf of myself and my wife. Okay, look at the finish on that. That's why I'm bringing you in for a close look here. It is as perfect finish, or perfect finish, as a fairly decent milling machine. That is the sort of result you can achieve with these small industrial CNC routers, but it takes a little longer, and the cuts are a little finer. Just for example, each depth of cut was 0.5 millimeters, and the feed rate was 12 millimeters a second. So that's about half an inch a second, and about a 16th, just no, under a 16th, about a 32nd of an inch cut. So it takes a little bit longer, but you can achieve perfect results. Well, so far so good. It's pretty well perfect matchup there, as much as I can cut cardboard anyway. But more importantly, look at the cut. Look at the cut, it's perfect. You probably wouldn't get a better cut than that on a dedicated milling machine, something like a toolpath. You can do it with these machines, albeit modified, providing you take your time, and small feed rates. So, I've just mentioned the name, or the manufacturer's name, toolpath, which is a beautiful machine. I'd have one myself. And a number of you have indicated, since I announced a couple of days ago that I was modifying, or having these machines modified to European and American standards, some of the comments have said, oh, so you're making Chinese rubbish. Well, actually, no, they're not. Let's get this right. They are made to European and American standards. And I'll just remind you, because maybe a lot of people out there don't know it, all the tool Mach machines are made in China under American supervision. And I will be doing exactly the same thing, or it's the same idea. So I hope that puts those couple of things to rest. Although the machine is made, or the machines and the equipment are made in China and Taiwan and Japan, because we will be using Taiwanese ball screws and in some cases German as well, and also Japanese stepper motors in some of the machines. So it's not all China. Most of the, should we say, the hard manufacturing, like the beds and what have you, yes, they will be done in China, because what we are attempting to do is sell you a decent, up-to-date machine at prices you can afford or that you really want to pay. So that's what we're trying to do. So we'll crack on then. We'll cut this piece out.